Let us recall the definitions of angle between the two planes and angle between a line and a plane by giving the examples as I decide. The very first one is, if two planes, say for example, first one is, if two planes 2x plus 3y minus 4z plus 1 is equal to 0, that is lambda x plus 3y minus 8z plus 2 is equal to 0 are perpendicular to each other. Perpendicular to each other. Then lambda is equal to dash. You know it better when two planes which are given in the form of Cartesian, that is a1x plus b1y plus c1z plus d1 is equal to 0, a2x plus b2y plus c2z plus d2 is equal to 0 are said to be perpendicular to each other. We have proved already a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So therefore, take this one as a1x plus b1y plus c1z plus d1. This is a2x plus b2y plus c2z plus d2 is equal to 0. They are perpendicular to each other. I can write this one as a1 a2 plus b1 b2 c1 c2 is equal to 0, right? c1 c2 is equal to 0. So therefore, a1 a2 2 lambda plus 9 plus 32 is equal to 0. So therefore, which implies 2 lambda is equal to minus 41. So therefore, lambda is equal to minus 41 by 2 is the required answer. So this is how you can go for the application of two planes are said to be perpendicular to each other under the condition that theta is equal to 90. As you know, when theta is equal to 90, we have found out already the angle between the two planes as cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. If I put theta is equal to 90 degrees, cos 90 is what? 0. So therefore, it becomes a1 a2 plus b1 b2 plus c1 c2 is equal to 0. With that concept, I could find out the value of lambda when two planes are perpendicular to each other. Yes, students, let us recall the definition of angle between a line and a plane. When a line is given, plane is given. So, if the angle between a line and a plane is theta, then the angle between a line and a normal is dash. We know that plane is always identified with a normal. When any line is make an angle theta, then it makes an angle 90 minus theta with the what? Normal. I have told yesterday, this is a plane, right? This is a line. What is this line? Let it be angle is theta. I take this reference as plane, right? So therefore, this is nothing but a normal. So therefore, this is 90. This is nothing but what? 90 minus theta. So therefore, I can represent if the angle between a line and a plane is theta, then angle between a line, this line, and a normal is what? 90 minus theta. This is how you can define the angle between a line and a plane, a line and a normal. If the angle between a line and a plane is what? Come on, yes, theta, then the angle between a line and a normal is what? 90 minus theta. Say for example, if I take first one is, if I take theta is equal to 30 degrees, What is theta is equal to 30? If the angle between a line and a plane is 30 degrees, then what is the angle between a line and a normal? The angle between a line and a normal is 90 minus 30. Therefore, is equal to 60 degrees, right? The first application. If I take the angle between line and a plane is 60 degrees, then what is the angle between a line and a normal is what? 90 minus 60 degrees. Therefore, is equal to what? 30 degrees. These are the conceptual questions that we can analyze with the definition of angle between the two planes, angle between a line and a plane, angle between a line and a normal. Nevertheless, if theta is the angle between a line and a plane, theta is the angle between a line and a plane, it is quite obvious, that goes without saying, the angle between a line and a normal is 90 minus theta. If theta is 30, it's what? Angle between a line and a normal is 60. If theta is 60, the angle between a line and a normal is what? 30 degrees. This is how you can analyze angle between a line and a normal respectively. Now, another conceptual question is the angle between the normals of two parallel planes. Yes, this is one plane, this is another plane. Then when two planes are parallel to each other, then it is quite obvious the angle between their normals is also what? Parallel. 0 degrees, aptly saying. When two planes are parallel, quite obvious normals are also parallel. Why? Because we have studied the angle between two planes is same as angle between their normals. Angle between two planes is same as angle between their normals. So therefore, I can say if two planes are parallel, the normals drawn to the planes are also parallel. When two lines are parallel, the angle between them is what? 0 degrees. Therefore, which one you have to go for? 0 degrees, 90 degrees, 90 minus theta, 90 plus theta? It is quite obvious. Since two normals are parallel, therefore the angle between them is what? 0 degrees. Since the angle between the two planes is same as angle between their normals. Yes, students, let us recall the definitions of angle between the two planes, angle between the what? Line and a plane. Yes, what is given? This is a straight line, a L with a DCS L, M, N is parallel to 3x minus 4y plus 2z plus 8 is equal to 0. 2z plus 8 is equal to 0, where the condition is dash. Look, the angle between the two planes is same as angle between their normals. Frankly speaking, actually there is no plane. Plane is there to say we are showing that a normal. You can identify plane is there with a line through what? Normal. Why? Because angle between the two planes is same as angle between the normals. When you cannot see, you must have the frame of reference or some reference through which you have to identify. So therefore, when ax plus by plus cz plus d is equal to 0, represents the what? Equation of a plane in a general form where a, b, c are the DRS of a normal. So therefore, I can write the proof of this one is the DRS of a normal for the plane 3x minus 4y plus 2z plus 8 is equal to 0. This is in the form of x plus by plus cz plus d is equal to 0. Followed? Therefore, what are the DRS? DRS of normal is equal to A, comma B, comma C. A is nothing but a 3 minus 4. It's a 2. 3, 4 minus 2. Now this is a plane. This is a normal, correct? When this is a normal, yes, a line with the what? DCS element is parallel to the plane. For this plane, this line is what? Parallel to this plane. Means this normal is perpendicular to this line. Why? What's the definition of coplanarity? The definition of coplanarity says, when any three vectors are said to be coplanar, they must lie in a same plane or the parallel planes. The vectors lying in a parallel planes are also taken into consideration of coplanarity. Lines are nothing but vectors here. Therefore, this is a what line or a vector parallel to this plane. Now it has a normal. Now when that line is what parallel to this is a normal. Therefore normal is perpendicular to that what plane. So therefore this is also perpendicular to that line. It may contain one line, it may contain two lines, it may contain any number of straight lines. For all those, this is perpendicular. Yes, ultimately normal is also a vector or a line. This is also a line. Normal is also a line. When any two lines are said to be perpendicular, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Why? The line is parallel to what plane? But it is perpendicular to normal. So therefore, since the line L is parallel to the plane, which implies L is perpendicular to the normal, which implies the condition is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Yes, now the line is having this is DCS. The DCS of a line are nothing but a what? DRS of a line. DRS cannot be a DCS. DCS can be a what? DRS. Therefore, these are also DRS. These are the what common DCS. I can take A1, A2, 3L minus 4M plus 2N is equal to 0 is a relevant condition for the line having a DCS L, M, N to be parallel to the plane. It is quite obvious it's a perpendicular to the normal. Therefore, L1, A2 plus B1, B2 plus C1, C2 is equal to 0. The equation of plane passes through the point P of 2, minus 3, 4 and perpendicular to x-axis. Perpendicular to x-axis means parallel to xy plane. So therefore, perpendicular to x-axis implies parallel to perpendicular x-axis means parallel to yz plane. Its equation is x is equal to lambda, or else if it is lambda, mu, gamma. Okay. Therefore, I can write this equal to 2, where P of 2, minus 3, 4 you can take as lambda, mu, gamma, delta, right? So therefore, now I can write this one as second one is, this is first one, perpendicular to y-axis, which implies parallel to zx plane. Its equation is y is equal to mu, which implies y is equal to minus 3. Next, third one is perpendicular to z-axis, which implies parallel to xy plane. Its equation is z is equal to delta. This is delta. So therefore, z is equal to what? I have taken 4. So therefore, take this as a 4. This is how you can find out the equation of a plane passing through the point P of 2, minus 3, 4 and perpendicular to x-axis. Perpendicular to x-axis means parallel to yz plane. Perpendicular to y-axis means what? Parallel to zx plane. Perpendicular to z-axis means parallel to xy plane. Why? Because for xy plane, z-axis is the normal. For yz plane, x-axis is the normal. For what? Next, if you go for other planes, similarly, y-axis will be the normal. So therefore, whenever an equation of a plane passes through the point and the perpendicular to x-axis are parallel to yz plane, perpendicular to y-axis, that is what? zx plane. Perpendicular to z-axis means xy plane is given by x is equal to lambda, y is equal to mu, z is equal to what? Delta. Now look here. We know that the angle between the two planes is cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus a2 square plus a3 square into square root of, that is b1 square plus b2 square plus b3 square. So therefore, now I can write, when two planes are perpendicular to each other, if you want, you can go for a1 a2 plus b1 b2 plus c1 c2. It all depends upon if a bar is equal to a1 a2 a3. If a bar is equal to a1 b1 c1, or next b bar is equal to a2 b2 c2, you can also change. According to that, okay, any condition, angle between the two planes is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Now, by using that concept, I want to find out the equation of plane through the line of intersection of these two planes and perpendicular to this. We have to apply angle between the line of plane passing through the line of intersection of this, and between this we have to apply angle is 90 degrees. With that, we are supposed to find out the equation of a plane. So therefore, what I do is, proof is very simple. Equation of a plane through the line of intersection of the planes is equal to, this is a plane 1, is given by x plus y plus z minus 1, pi 2, 2x plus 3y plus 4z minus 5 is equal to 0. I can write as x plus y plus z minus 1 lambda into 2x plus 3y plus 4z minus 5 is equal to 0, right? You call this one as, you try to simplify this, 1 plus 2 lambda into x, 1 plus 3 lambda into y, 1 plus 4 lambda into z, minus, you call it as 1. Both are same. I simplified this in the form of a1x, b1y, c1z plus a d1. Right? Now given 1 is perpendicular to, what is this? The plane x minus y plus z is equal to 0. If I take this as a1x, b1y, c1z, d1, this is a2x, b2y, c2z plus d2, where d2 is equal to 0. So therefore, what I do, perpendicular, then the condition is, a1, a2, b1, b2, c1, c2 is equal to 0. Now, with this condition, apply 1 plus 2 lambda into 1. Next, 1 plus 3 lambda into this. Next, z 1 plus 4 lambda is equal to 0, right? So therefore, I can write 1 plus 2 lambda minus 1 minus 3 lambda, 1 plus 4 lambda is equal to 0, this and this. Therefore, now minus 3 lambda, 6 lambda, 2 lambda plus 4 lambda, 6 lambda minus 3 lambda. Therefore, 3 lambda plus 1 is equal to 0. Lambda is equal to minus 1 by 3. Take this value of lambda and substitute either here or here as you please. So therefore, I can write 1 implies x plus y plus z minus 1 by 3 into 2x plus 3y 4z minus 5 is equal to 0. So therefore, I can write, this implies cross multiply 3x 3y plus 3z minus 3 minus 2x minus 3y minus 4z plus 5 is equal to 0. Now simplify, which implies x, 3y goes, right? Next, 3z minus 4z minus z plus 2 is equal to 0. This is the required answer. So therefore, what we followed is the equation of plane through the line of intersection of these two planes as plane 1 lambda into plane 2 is equal to 0. This plane 1 is given by this, plane 2 is given by this. Substitute. This is same as 1, this is also same. Arrange in a standard form. This plane is perpendicular to this. We know it already. When any two planes are set to perpendicular, a1, a2 plus b1, b2 plus c1, c2 is equal to 0. If they are parallel, a1 by a2 plus b1 by b2 is equal to c1 by c2. The same problem can be given to, instead of perpendicular, I can also write parallel. This is parallel to what? X minus y plus z is equal to 0. So therefore, instead of this, you apply a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Then you get a value of lambda. Take that lambda and simplify, you substitute here. That gives the equation of a plane passing through the line of intersection of two planes parallel to another plane. At present, we are discussing about perpendicular. This one is, instead of parallel condition, we are applying what? Perpendicular condition. This is how we can use the concept of angle as well as concept of a plane passing through the line of intersection of two planes. Now, when the two planes are given, kx plus y minus z is equal to 9, x plus 2y plus z is equal to 7 is pi by 3. Then k is equal to dash. K is equal to dash. Okay. So therefore, what I do is, when two planes are given, the angle between the two planes is pi by 3. K we are supposed to find out. So now let us start. When the angle between two planes pi by 3, then cos pi by 3 is equal to a1 a2 b1 b2 c1 c2 a1 square plus b1 square plus c1 square a2 square plus b2 square plus c2 square. This is how you can write. So therefore, what is cos pi by 3? 1 by 2 a1 a2 k b1 b2 2. This is what? Minus 1 by square root of k plus 2 into, yes, come on, 1 plus 4 plus 1. So therefore, now you cross multiply. This becomes root k plus 2 into root 6 is equal to k plus 1. Now 2k plus 2. This is squaring on both sides. You get this one as, yes, come on, k plus 2 into 6 is equal to 2k plus 2 whole square. Expand it. 6k plus 12, 4k square plus 4 plus 2 into 4, 8k, right? That is 4k square plus 4 plus 2ab. Now therefore it becomes 8k. Now I can write 4k square plus 2k minus 12 is equal to 0. Yes, simplify. That gives the value of k. What? Factorizing this chord equation, you get the values of what? K. This is how you can find out the unknown under the angle. I mean, when the angle between the two planes is what? Something 60 degrees. Then this is how you can find out the value of what? K. Now coming to, look here. There are three planes, 1, 2, 3. Such that why plane 1 is perpendicular to plane 2. Plane 1 is parallel to plane 3. If n1, n2, n3 are the normals to the what planes, plane 1, plane 2, plane 3 respectively, then n1 is parallel to n3. n1 is perpendicular to n2. Next, n2 is what? Parallel to what? n2. n2 is what? Parallel to? Yes, you can take this one as what? n3. You can take this as n3. n1 is perpendicular to n2. Next, n1, n2 are parallel to x-axis. n3 is parallel to what? Y-axis. Yes. First, read the given data carefully. It's a very much conceptual question. Why? Because we know that angle between the two planes is same as angle between their normals. Angle between two planes is same as angle between their normals. So therefore, now he has given n1, n2, n3 are the normals to the respective planes. Given the condition, what's the given condition? The condition is what? There are three planes such that plane 1 is perpendicular to what? Plane 2. Plane 1 is perpendicular to plane 2. Angle for a plane 1, n1 is the normal. For plane 2, n2 is the normal. When plane 1 is perpendicular to plane 2, it is quite obvious. The normal to the plane 1 is perpendicular to the what? Normal to the what? Second plane. So therefore, the angle between n1 and n2 is what? 90 degrees. n1 is perpendicular to n2. Meanwhile, yes, plane 1 is parallel to what? Plane 3. As you know the definition, angle between the two planes is same as angle between their normals. When plane 1 is parallel to what? Plane 3, the normal drawn to the plane 1 is n1. The normal drawn to the plane 3 is what? n3. Therefore, it is quite obvious. N1 is parallel to N3. N1 is parallel to N3. So therefore, we can say that, what's option? Check the option carefully. N1 is parallel to N3. Yes, what I told is correct. Plane 1 is parallel to plane 3. Plane 1 is parallel to plane 3 means N1 normal, N3 is the normal. Therefore, N1 and N3 are what? Parallel to each other. That's what? Correct. Let us see. N1 is perpendicular to N2. N1 is perpendicular to N2. So therefore, let us see. The plane 1 is perpendicular to plane 2. Plane 1 is perpendicular to plane 2 means then N1 is the normal for first plane, N2 is the normal for what? Second plane. So therefore, the angle between the normal N1 and N2 is what? 90 degrees. Therefore, N1 is perpendicular to N2. Therefore, N1 is parallel to what? N3. So therefore, the correct apt answer is first option, option A. That is, N1 is parallel to N3 and N1 is perpendicular to N2. Yes, now look here. Students, let us find out the equation of a plane passing through the line of intersection of two planes. Then, first one, parallel to x-axis. We have already discussed about perpendicular x-axis. Perpendicular x-axis means parallel to what? YZ plane. Here, parallel to x-axis. That is different. That is perpendicular. This is parallel to x-axis. Second one, other problem, parallel to y-axis. Other problem, parallel to what? Z-axis. Let us see. What's the equation of a plane? Now the equation of a plane. I am supposed to find out equation of plane. Equation of plane passing through the line of intersection of planes is equal to 0. You call this as required plane. And I'm supposed to find out what is plane. X minus y plus z minus 2 lambda into 2x minus y 2z minus 5 is equal to 0. Minus 5 is equal to 0. You call this as what? 1. Okay. Now I can also rewrite 1 plus 2 lambda into x. That is minus of minus 1 minus lambda into y. This is 1 plus 2 lambda into z. Next, minus of 2 plus 5 lambda is equal to 0. This is also 1. Now we have found out the equation of a plane passing through the line of intersection of two planes. Again, 1 plus 2 lambda minus 1 minus lambda. 1 plus 2 lambda into z minus 2 minus 5 lambda. Got it? This plane is parallel to x-axis. When any plane is parallel to x-axis, x coefficient is equal to 0. So therefore, now I can write case 1. When 1 is parallel to x-axis, x coefficient is equal to 0. What is x coefficient? This is. Therefore, 1 plus 2 lambda is equal to 0. Therefore, lambda is equal to minus half. Take this, dump in 1. So therefore 1 implies, what is that? Now 1 implies, here also you can put, yes, come on, 1 minus, look here, 1, 2 into minus 1 by 2, it becomes 0 into x. Next plus minus 1 plus f into y. Next, now I can write here minus of, you can put, this becomes what? 1 plus 2z. Yes, now this becomes 0 into z minus, this becomes 2 minus 5 by 2 is equal to 0. So therefore I can write minus f into y, this is what? Take LCM, plus f is equal to 0. Therefore y minus 1 is equal to 0 is the required answer. In the same fashion, I can go for, that is case 2. What is case 2? When 1 is parallel to y-axis, y coefficient is equal to 0. In 1, what is that? Minus 1 minus lambda is equal to 0, which implies lambda is equal to minus 1. So therefore 1 implies this is the required plane. So you substitute here, that is lambda minus 1, therefore minus x. Here now this becomes minus 1, 0. Next here, that is a minus z, here plus 3 is equal to 0. Therefore now I can write x plus z minus 3 is equal to 0. This is the equation of a plane parallel to y-axis. Now I go for case 3. What is case 3? The case 3 is when 1 is parallel to z-axis, which implies z coefficient is equal to 0. Z coefficient of 1 is 0. What is this here? Now 1 plus 2 lambda is equal to 0. Therefore lambda is equal to minus f. Now you substitute here minus of, this becomes, now this becomes 0, 0. This becomes what? That is minus f. Why? Because plus f minus f into y, this becomes 0. This becomes minus 2 minus 5 by 2 is equal to 0. So therefore I can write minus y by 2, yes, come on, plus 1 by 2 is equal to 0. So therefore I can write y minus 1 is equal to 0. This is the answer, right? So therefore, we have found out the equation of a plane passing through the line of intersection of two planes. So is given by plane 1 plus lambda into plane 2 is equal to 0, and he has given how to find out the unknown lambda. In one question only I did all the three. Of course you may coincide with that one, that's not a matter. How to introduce the concept is most important in understanding that in a user friendly. So therefore now this is a plane passing through the line of intersection of two planes. I got it. This also one, this also one. What is unknown? The unknown is what? Lambda. To find the lambda, so when it is parallel to x-axis, x quotient is equal to 0, parallel to y-axis, y quotient is equal to 0, parallel to z-axis, z quotient is equal to 0. So substitute the corresponding values of lambda, what we got it in the equation 1. That gives the equation of a plane parallel to x-axis, parallel to y-axis, parallel to z-axis.